Okay, more in chapter 3 is once we have the center down, we want to talk about the spread, the measure of variation. How much do the data points vary amongst themselves? What's the spread? What's the range? Apparently, we're going to do range, deviation, variance, and standard deviation. So, range we've seen before, the difference between the maximum and minimum data value. Remember, the range is one number. It's the minimum, literally the calculation, minimum, maximum minus minimum, okay? The deviation, how much does each data value deviate from the average of the data, okay? So one value in a population, how much does that one value change? Deviate from the mean. So if the mean, let's say the mean's 45.3, okay, and this value right here was like a 52 or something, that would give you the deviation, the mathematical deviation from that 1 point was from the average, okay? In the sample, we're talking about that one value from your average sample mean, right? This is the mu is the symbol for the population average mean, and the X bar is the symbol for the sample mean, okay? To get the standardized deviation, how much do they all kind of as bulk deviate from the mean? Do they vary a lot from the mean, or do they vary a little from the mean? Are the data points all spread out, or are they hunkered all close together? Okay, if you take all of these deviations from each point and add them up, you're actually going to get a zero mathematically. So to overcome this problem, you can square each deviation, and then you add the squares. You compute a quantity called the sum of the squares. So the mean of squares of the deviations is called the variance, and then the square root of the variance is called the standard deviation. Okay, so it's kind of a rig to figure out the spread. So we have some formulas to follow and some new symbols to learn. So the population standard deviation is this little kind of circle with a loop here. Sometimes you see a little open swirl, but it's called a sigma. And the sample standard deviation is just a simple S for sample, okay? The formulas are similar depending on if you're using frequencies or not. And then the variation is just simply that squared. Okay, to find the variation, you want to use your standard deviation rounded to 5 or 6 decimal places if it's non-terminating. If you get 4 decimal places in a standard deviation, you should use 4 decimal places. But if it goes on forever, use 5 or 6 and that'll be good enough. The rounding rule for standard deviations is the same as that for the mean. The final answer should be rounded to 1 or more decimal places, one more decimal place from the original data. Okay. So, for example, large corporation has several branches. They plan to use the starting salaries of a Chicago branch to estimate the starting salaries for all the branches. To find, by the way, that's a cluster type of sample, right? Because you're grouping them into the different branches, and then you're picking all from one branch. Okay, the starting salaries. And then we want to find the mean, median, mode, range, variance, and standard deviation from all the starting salaries. Okay, so here's our data points right here. Okay. These are starting salaries at the Chicago branch in $1,000 units. So somebody makes $41,000 for their starting salary. Okay. So I ordered them. And then, because I was asked for the median, and I counted them up, and there's my 10, okay? So if you notice here, the most repeated is the 41. So 41 is the mode, or 41,000 is the most common or typical starting salary at this Chicago branch. The median value, the center value, is between, because it's an even number, between the fifth and the sixth value. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So kind of, it's in here somewhere, so it's definitely 41. Okay. Then the range, we have the minimum and the maximum. So min from max is 10. 10,000 is the difference between the lowest starting salary and the highest starting salary. And then to find the mean, all we do is add them all up. And remember, there are 3 41s, okay? And then divide by 10, so you get your sample mean. So 41,500 is the average starting salary. All right, so that takes care of the mean, median, mode, range, and the standard deviation. We had that formula, okay, that was on the last page. Let's look at that for a second again. Sorry. We have a sample. So this is what we're looking at here, okay, and let's go back over here. So we're going to be putting them in these. Here's the frequencies. I've laid them all up. Here's the 41 had 3 of them, right? There's our data values. There's the frequency of the data values, the deviations themselves, right? How much that one data value varies from the average. You get a total right there, right? And then we're going to square that total. And then we're going to multiply it by the number of frequencies, okay, for each data point. Over here, don't forget, when you got the 3 of them, right there, that's going to make the difference because I have 3. I'm multiplying it by the frequency. So that gives you that. Okay, yes, you got to do for each one, because remember, we then need the sum of. So here's our sum. When we add all these numbers up, we get this total. And according to the formula, that's the number that goes on top. And then we subtract your n minus 1 for the sample variance, which gives me this number. Obviously, it's a repeating 3, so I need 5 or 6 decimal places to square root it to get my standard deviation, my sample standard deviation, my S, which comes out to 3.1. All right, so you're just going to have to get this chart out and do that every time and follow it. It's not hard. Just gotta, I would make a chart every time, okay? It's up to your instructor whether you're using any technology to shorten this step.